For lesson 1-4, we're going to evaluate square roots and cube roots. So example 1, we're going to evaluate. Problem A, square root of 25. One way we could do this is to think about what times itself is 25. So you kind of think through your multiplication facts, and you probably remember that 5 times 5 is 25. So the square root of 25 is the same as saying the square root of 5 times 5. Another way we can write that, 5 times 5 is 5 squared. And one very important fact to realize when dealing with square roots is that a square root symbol and then the little exponent 2, which is a square symbol, those are inverses of each other. That means they're opposites. They undo each other. Kind of like adding and subtracting are inverses of each other, or multiplying and dividing are inverses of each other. So when I take the square root of 5 squared, the square root undoes the squaring 5, and we just get 5. Now let me show you this with a calculator. On the calculator, you type second the square root button, then the number 25, close your parentheses, and hit enter, and you get 5. Part B, we're evaluating the cube root of 64. Notice that it's a cube root because in the bend of the root symbol, it's got the number 3. And that tells us that we're trying to figure out what number that when multiplied by itself to have 3 factors, that number times itself equals 64. And you might think through your math facts and realize that that might be the number 4, and you could check in your head and think, well, 4 times 4 is 16, times 4 is 64, so that works. So I'm going to rewrite this cube root of 64 as the cube root of 4 times 4 times 4. And then, like we did with the square roots, 4 times 4 times 4 is 4 times itself 3 times. So we could rewrite that as the cube root of 4 cubed. And just like a square root undoes a square, or the exponent 2, a cube root undoes a cube, or the exponent 3. So the cube root of 4 to the 3rd power is just 4. Now we'll look at that on a calculator. Okay, when we go to the calculator, there is going to be a new button that we look for. You'll notice on the left side of your calculator, about halfway down, there's what looks like a square root symbol with an X in that little bend of the root symbol. We use that to plug in whatever number root that we're dealing with. So in this case, we're dealing with a cube root. And in 8th grade math, we will only deal with square roots and cube roots. So this is the only time you're going to use this button in 8th grade math is for a cube root. So you'll notice that X root button. You first type in 3 for a cube root, then second, X root, don't use parentheses, and type in your number, enter. Notice that we didn't have to close a parenthesis because it did not open a parenthesis. And so it was as simple as that. Example 2, we have a little word problem. A toy company makes cube-shaped blocks with a volume of 216 cubic centimeters each. What is the length of an edge of a block? So when we're dealing with the edge of a cube, it's just like the side of a square, except that a cube is multidimensional. So we're going to look at just one edge. Let's take this edge here. We know that an edge is just one side of a cube, so we could say that edge or side times another side equals the volume, because that's 3 dimensions. So when we do that, we're really trying to figure out what the cubic root of 216 is, because that's the volume. So the cubic root of 216. That is like trying to figure out what number times itself 3 times is 216. And if we think through, we know it's larger than 4, because 4 times 4 times 4 is 64. So you can kind of just go through your numbers. You could try 5. 5 times 5 times 5 is 125, so that doesn't work. But if we go a little larger, 6 times 6 times 6 is 216. So when we take the cubic root of 6 times 6 times 6, that's 6 cubed. And the cubic root of 6 cubed is 6. So the length of an edge of a block is 6 centimeters. So looking at a calculator, remember that we need to do the 3 first for cube root. So we do second, x root, type 216, and hit enter, and we get 6. So you could either use the method given writing it out, or you can go to a calculator. But in all, when we've done that, we see that one edge is 6 centimeters. So that means, since it's a cube, that the height, the length, and the width are all 6 centimeters, and 6 times 6 times 6 is 216. So that one worked. Okay, so now that you have gone over some examples, I'd like you to try a few problems. So take a few minutes, pause the video, and try these problems, and I'll go over the answers with you in just a little while. Okay, so for number 1, what times itself 3 times equals 27? That would be 3 times 3 times 3. So we'll get 3 on number 1. On number 2, you're thinking what times itself is 81, because it's just a square root. And so that would be 9 times 9. So our answer is 9. On 3, what times itself is 49? That is 7. Since it's a square root, we're just thinking of a number times itself once. So 7 times 7. Number 4, cube root of 1. Well, what times itself 3 times is 1? Well, that would have to be 1 times 1 times 1. By the way, the square root of 1 is also 1. The number 5 and 6 were a little bit of a challenge because we haven't looked at a problem exactly like these, but I wanted you to try them. On number 5, notice that we have 2 different roots separated by an adding sign. So we kind of think back to order of operations. And we'll do square root of 36 first, which is 6. Bring down your plus sign, thinking of order of operations. And the cube root of 125 is 5. So now that we've found both of these roots, we're just adding them together, 6 plus 5, which equals 11. Number 6 is also a little different. We have the square root of 79 plus 21. So we actually have a group within this square root. And if we think about order of operations, the square root symbol is kind of like a parenthesis. We're going to work what's inside that grouping symbol, that parenthesis, first. So in that grouping symbol, that kind of like a parenthesis, we have 79 plus 21. So when we add those, we get 100. And the square root of 100 is 10.